Hello, I am going to talk about Riemann sums. And the definite integral. Okay, sorry, that doesn't look very nice. Okay, so just to start with kind of the idea behind this idea, we kind of started talking about, okay, so we have some curve. Let's just make it x squared plus 1. Okay, well, if we wanted to find the area under it from an interval from, let's just say 1 to 4. Say we want to find that area that's underneath it. And I'll talk in a minute about why we'd want to do that. But let's just say, just for now, we just want to do that. We want to find this area here. Uh, how can we do that? We don't really have a formula for just some random area under a curve like we do with rectangles and triangles and circles and all of that. So one thing that we could do is we could break it into rectangles. So let's just say for this one, we're going to break it into 4 rectangles. So we're going to break into 4 rectangles. So we have the width of each rectangle, which is what we call delta x, the width of each rectangle will be our end point minus our start point divided by, let's do 3 to make this nicer. Sorry. Let's do 3. Okay, divided by 3. Okay, so that's going to be 3 over 3, which means each rectangle is going to be a width of 1. So we're going to break this interval will be broken into smaller intervals, and that's going to be of a width of 1. So the next one will be 2, and the next one will be 3. And that will allow us to draw these triangles. Now there's 2 ways to draw it. You can do a left endpoint, which means you start on this left endpoint and you go over and you draw down a rectangle. Then you go like this and draw down, and then you go and notice I'm drawing these points on my curve because I'm trying to approximate it. That's the goal. So I'm drawing them on the curve to try to get as close as I can. Okay, so these are, left endpoints. And then I could say, okay, well, I don't have a formula for the area under this curve, but I do have a formula for rectangles. So I would find the area of each rectangle. So the area of my first rectangle is going to be the width times the height. But if you notice the height on this rectangle is just my y value here. So how do I get this y value back? I plug in this 1. So it's going to be the width of the rectangle, which we found was 1, times the height, which means we're just going to plug in a 1 into our function. This was our function. And then the area of the second is going to be the width times the height. Well, now we're just going to plug in the 2 into our function. And then the third rectangle will be the width times the height. And this height, we're just going to plug in a 3 because we're right here. And then we can just add these up. So we get the formula is, notice each time we multiply by the width. So we get, well, let's just do this. So 1 times 1 squared plus 1 times 2 squared plus 1 times 3 squared plus 1, which is the same as just 1 times 1 squared plus 1 plus 2 squared plus 1 plus 3 squared plus 1. And so we can see that we just, we can add these up. So 1 plus 1 plus 4 plus 1 plus 9 plus 1 will give us 3, 4, 8. So we'll get 17. And so this is our approximate area from 1 to 4. That's x equals 1 to 4. Okay, and then we could have done another route. We could have done, instead of doing these left, um, instead of doing these, oh, sorry, let's try to get this better. Uh, Instead of doing, here, I had 1, 2, 3, and 4. I could have drawn these rectangles a different way. I could have started here and kind of come across this way. And notice each time I'm just pretending like my function's constant, like I just have a constant y value here. I'm going to come up here and just kind of draw it, pretending like I have a constant y value. And I'm going to come up here and just kind of draw it, pretending like I have a constant y value there. Now I still have 3 rectangles. The width of each rectangle is still 1, but now I'm using the right endpoints. And again, I can find the area of each rectangle, except now, so I have it divided into my 1, 2, 3, 4. Except now I'm not plugging in my first point. I'm plugging the next one over. So now I would plug in into my function 2 squared plus 1, you know, and then plus the 3 squared plus 1, and then plus I end with my right endpoint. And then all that times the width of the rectangle, which is just going to be 1, so it doesn't really matter. So that's 4 plus 1 plus 9 plus 1 plus 16 plus 1. So I'm going to get, let's see, 16, 20, 29, 30, 31, 32. So 32. And so you can see that one's going to be greater and one's going to be less, because this is still an approximation, but it's just an overestimate. Okay, so why don't you do this? Why don't you approximate? So we have our function is x squared over 2, and we're going to go from x equals 2 to x equals 8. So approximate that area using 3 rectangles and left endpoints. So go ahead and pause the video and see if you can do that. Okay, so the first thing that we kind of need to do is just find the width of each of those rectangles. So we know that we're going to end at 8, we're going to start at 2, and we're going to have 3 rectangles. So we're going to have, each rectangle is going to have width 2. And now we kind of just want to break up that interval. So we're going to break up that interval that we're using. So into groups of 2, like with a distance of 2. So this is going to be my first rectangle. We'll go from 2 to 4 to 6, and then I end at 8. And then now I want to just kind of plug in. So if I'm using left endpoints, I'm going to start by plugging in this 2 and go across. So I'm not going to draw each one, but I'm going to have the width of my first rectangle times, I'm going to plug in a 2 into my function, which was x squared over 2. Remember, my function was x squared over 2. So I'm going to plug in my 2 divided by 2 plus, I'm going to plug in my 4. Well, actually, let me write this different. So that will give me my first rectangle. And then the width times the height, which is going to be, now I'm going to plug in a 4 next. The width times the height, but now I'm going to plug in a 6. And then I stop there because I'm using the left endpoints, so I don't finish with an 8. So I can go ahead and pull out that 2 because it's being multiplied at all. And then I just have, 2 squared over 2 plus 4 squared over 2 plus 6 squared over 2, and that will give the approximate area with left endpoints.